is pressure? What is pressure? Now, let's see if you understand this diagram. Okay, these are two fingers of a same person. In between the fingers, this person is holding a thumb pin. Okay, this is finger A. This is finger B. Finger A and finger B. Now, what is this? This is a thumb pin. I hope you understand what thumb pin is. It has a fat head on one side and very pointy nail-like structure on the other end. Now, if this person, not very hard, just slightly exerts a force inward like this, and exerts an equal force from both sides. Which finger will be in more pain and why?
Finger B.
And why?
Because pressure and area are inversely proportional.
If same force is applied on both fingers, finger B will feel more pain than finger A. Now, why is that? Because pressure is a kind of density of force. How much force is acting on a unit area? So pressure is force acting per unit area. P equals to F over A. Unit for force is newtons. Unit for area is meter square. So what will be the unit for pressure?
Newton meter square.
Newton per meter square. Not Newton meter square, Newton per meter square. So this has another name known as pascals. Now, pressure and area are inversely proportional. What is the difference between dull knife and sharp knife?
The sharp knife has a higher pressure because it has a very small area.
Yes. When we are sharpening a knife, actually we rub it from both sides. So the edge of the knife becomes smaller. Actually, it should have as small area as possible, and that will make the knife sharper. All we are doing is reducing the area of the edge. Small. That is why we rub it from the sides. I hope you have seen that when we are sharpening a knife, we do not just rub the edge on the surface that we are like on the sandpaper. We make the sandpaper go on the sides, so it helps to reduce the area of the edge and make the knife sharper. So dull knife has flat edge, so more area, hence less pressure with same force. This is why if you have a dull knife, you have to exert more force to cut something. Sharp knife, less area of edge, hence more pressure with same force. Now, pressure is a relationship between force and area. Question: what is meant by pressure of 1 Pascal? Answer: if a force of 1 Newton is applied on an area of 1 square meter, a pressure of 1 Pascal is applied. So if a force of 1 Newton acts on an area of 1 meter square, that is 1 Pascal of pressure. Pressure in liquid this is a container. In this container, there is a liquid like this to a height of h. This area of base is A. Area of base is A. H is height of column of fluid is h. density of fluid inside is rho. This is container. Now, what is pressure of fluid? Now, pressure of fluid equals to force over area. Where force on base equals to weight of liquid weight of liquid equals to volume of liquid multiplied by density. So in this case, density is easy to know. It is rho. What is volume? Sorry. Weight of liquid is mass of liquid multiplied by gravitational field strength. Now, gravitational field strength, everybody knows it is G, 10 meter per second square. What is mass of liquid? Mass of liquid or fluid will be volume of liquid multiplied by density. Density is easy. What is volume of liquid?
Mass of liquid divided by density?
No, base area multiplied by height.
Oh, okay. I thought we had to rearrange formulas.
So now we will go back and keep installing things into one another. So if volume of liquid is base area into height, so mass will be, because it is volume multiplied by density, it will be AH into rho. Okay. See, mass of liquid was volume multiplied by density. If density is rho, so it will be AH rho. Weight, which is equal to force. Force equals to weight equals to mg, mass into gravitational acceleration. So it will be AH rho into g. So pressure equals to AH rho g, force over area. So I can see area and area get cancelled. So pressure of liquid is rho g and h. This is a very famous and very useful formula for pressure of fluid. There are some important things in this formula. No. Okay, now pressure equals to rho G and H, where P is not any pressure, pressure of fluid, pressure of fluid. G is gravitational field strength. Rho is density of the fluid. What is H? What is H? The one? Okay. H is
The height.
height of column of fluid from point inside the fluid to the surface. So actually, some people think that it is the height of the object. No, it is the height of the fluid above the point. So if there is this lake, and there's some scuba divers diving, okay. So this is A, this is B, this is C. They are all in water. Which one will have more pressure because of the fluid?
C.
So apparently, it looks like that if we are thinking of height of the point, then A should be the highest one. But actually, when we say height, we actually mean height above the point. So this will be the height of column of fluid above A. This will be the height of the column of fluid about B. And this will be the column of the fluid above C. So now, which one has A, B, and C? Which one of these three has more fluid above it?
C.
That's why C will be under maximum pressure. Pressure on C is more than any other person in that pound. Okay. So A is under least pressure, C will be under maximum pressure. Pressure of fluid changes with depth under the surface. Okay, as you go deeper, pressure increases. A pressure related question. An examiner is never tired of asking this question. Question. Why do molecules of gas exert pressure on the walls of the container? So there is a gas which is trapped in a container. Why do the molecules of gas exert pressure on the wall of the container? Answer.
Is it because they're constantly colliding with the walls?
Yes. But this will be a 3-mark question. Do you think you should get 3 marks for just mentioning that?
No.
But that would be one of the marks of the gas molecules are always in very high kinetic energy. Gas molecules are always in very high kinetic energy. They move and continuously hit the walls of the container. Gas molecules are always in very high kinetic energy. They move and continuously hit the walls of container. In every collision, their momentum changes, which produces an impulse. Every collision, in every collision, their momentum changes, which produces an impulse, which produces an image impulse. Rate of change of momentum produces force on the walls So we are discussing that why gas molecules are exerting pressure on the wall of the container. First thing, we established that the gas molecules are continuously moving. They hit the wall of the container. With every collision, they experience an impulse, change of momentum. The rate of change of momentum produces force on the wall. Force per unit area is called pressure. So this is how gas molecules exert pressure on the walls of container. Confusion?
Oh, sir.
Any confusion?
No, sir.
Good. This is wall of container. If this is the ball that is coming towards the wall with a velocity of say 5 meter per second, and then it comes back with a velocity of minus 3 meter per second square. What will be the change of momentum for this one if mass is say mkg? So change of momentum will be 5m minus 3m. Actually 8m kg meter per second will be the momentum change of momentum. So be very careful when direction is back with a velocity of minus 3 meter per second. Change in momentum will be 5 minus 3, 8 m kg meter per second. Okay. This is where the topic of mechanic should end. Okay. So we can do some past paper questions. And there will be a class tomorrow, same time. Okay.
Sir, can we do it any earlier?
I hope you understood.
Sir, can we do the class tomorrow any earlier?